All right, welcome back to day 2 of Unit 1. We're still talking about scientific inquiry, but today's aim is what is the importance of the scientific method? So today we're going to be learning about the steps of the scientific method, as well as why it's important. All right, so as always, make sure you have your notes page out and ready to go as we follow along with this video. So your do now today is read and respond to the text below. I want you to read that passage on your own, but the question you're going to be answering is it okay to just accept what scientists say? What reasons do you have to believe them? So pause this video, answer that question on your own, and when you are done, press play. So is it okay to just accept what scientists say? I know a lot of us probably said yes, and we want the answer to be yes, right? We want to believe that we can just accept what everyone says as fact. But unfortunately, the answer is no. It's not okay to just blindly accept what scientists say. And this brings in the concept of scientific validity. So you will see the word valid or validity on the Regents exam a lot. And you might be wondering, well, what does that mean? Okay, so a few years ago, I'm not sure if it's still slang, but my students would always say like, yeah, miss, that's valid. And I asked them, I was like, well, what do you mean that's valid? And they were like, like it's facts, it's true, it's real. And that's exactly what scientific validity is as well. So if something is valid, it's based on facts, it's well researched, and it's true. Okay, so validity is based on facts, and it's well researched. Okay, now I'm bringing up the concept of scientific validity for a few reasons. But mostly because as scientists, it's always our job to be evaluating the facts behind something and evaluating the research and making sure that it's done right. Because unfortunately, bad science has been used to justify a lot of really terrible things throughout history. And one of these examples is several years ago, I'm sure you guys have heard of this, a scientist came forward and said that he did an experiment and he found out that vaccines cause autism. Now, this has been proven false time and time again, but because that experiment was published, a lot of people still believe that vaccines cause autism. So the damage has been done. Even though his experiment was not valid and it has been proven to be wrong, people still believe it. So it is constantly our job to make sure that we are thinking critically about the science and making sure that these scientists have done their research right. So what reasons do you have to believe scientists? Well, if it's done correctly, that scientists should have done their research based on the scientific method. And today we're going to go through these steps and what each of them mean. So the first thing you do when you're using the scientific method is you're going to ask a question. Remember yesterday or on Friday, my question was, what am I allergic to? So it's going to be something that you're curious about. Once you've done your research, you're then going to create a hypothesis. We call our hypothesis an educated guess, but I want to make this clear. Your hypothesis is not a question, so should not be written as a question. All right, so our hypothesis is actually going to be a statement, and I want it to be written as an if-then statement. And I'll give you an example of this in just a minute. So you're going to write if ... then ... But your hypothesis should end in a period. It is a statement. So that's your educated guess about what's going to happen once you run your experiment. So then the third step is you actually do your experiment. Remember, my arm experiment was that I put the different skin products on my arm and I tested to see which ones caused an allergic reaction. So this is where you make a plan and you test your hypothesis. While you are doing this experiment, you should be collecting data. That's when you record your experiment's results and your observations. The fifth step is where you analyze, where you review and draw your conclusions. Okay, your conclusion is where you determine whether or not that hypothesis is true or not. Okay. So then number 6 is your report. This is where you explain your results and whether or not your hypothesis was correct. Okay. We're going to be learning about these steps more in the upcoming days. So I know this was just a brief overview. I don't want to make this video too long, so I'm trying to be quick with this. Today we're going to be focusing on step 3, the experiment. We're going to be learning about some vocabulary that goes along with experiments and some things that you absolutely need to include in those experiments along the way. All right, so here's your vocab of the day. Number 1, we've got a testable idea or explanation that can be assessed through further investigation and experiment. I'll give you a hint because I know that's a really long definition. We also call this our educated guess. Okay, so the first vocabulary word is going to be hypothesis. Ooh, my handwriting. This is a testable idea. It's something that you can test in your experiment to see if it's right or wrong. All right, the second vocab word is the variable being tested and measured in experiment. So I want you to underline the word measured or highlight it, because that's really going to be how we distinguish between these two variables. If you are measuring something, that is your dependent variable. You might also see this abbreviated dV. All right, next up, we've got the variable that is changed or controlled. You might also see this referred to as manipulated, because if you are manipulating something, you're changing it. So the variable that we are manipulating in an experiment or changing is our independent variable. And you might see that abbreviated IV. All right, that recording went out for a minute, but I think we're back. So where we left off, the group in an experiment that receives the variable being tested. You would also see this written as it receives the independent variable. So the group that receives the independent variable is going to be your experimental group. Right? And the group in an experiment that does not receive the variable being tested or does not receive the IV is going to be your control group. So why do you think we need a control group? Why can't we just do the experiment and then carry on with our day? Well, you need a control group because you have to have a baseline of data to compare your results to. So we have to have a baseline of data to compare results to. Because if we don't have a control group, there is nothing to compare our results to, and there's no way to prove that there is a relationship between the independent and dependent variable. All right, I'm still working on multitasking between writing and speaking, so bear with me as we go through this. All right, now I've got an example for you guys. I'm going to read through this passage. We're going to answer these questions, okay? The electronic cigarette, an item that can satisfy a smoker's nicotine craving without burning tobacco, has been on the market for over 3 years now. This device has not yet been linked to cardiac disease, cancer, or chronic respiratory disorders, which are commonly related to smoking tobacco cigarettes. An e-cigarette consists of a rechargeable battery as well as a small cartridge which contains liquid nicotine. The battery is used to heat the cartridge, which in turn allows the liquid nicotine to turn into water vapor. Though markers of the e-cigarette often herald their product as a much healthier alternative, local researchers are interested in determining whether this new fad is actually a fast track to becoming strongly addicted to nicotine. They have designed an experiment including 10,000 cigarette smokers, 5,000 of which were asked to switch over to the e-cigarette. The researchers plan to monitor how many cigarettes the people in each group smoke per day. The data from this experiment will allow the researchers to conclude whether the e-cigarette causes an increase in smoking, indicating a greater extent of addiction. All right, so using that passage, Number one, what are the local researchers testing? Okay, well, we read right here that the researchers are interested in determining whether e-cigarettes are a fast track to becoming strongly addicted to nicotine. So they're testing, are e-cigarettes more addictive than regular cigarettes? All right, so number two, what are the researchers manipulating, or what are they changing? Okay, so they're changing which type of cigarette is smoked. So are they going to be smoking e-cigarettes or regular cigarettes? So I'm going to write they're manipulating smokers switching to e-cigarettes. Or let's just write e-cigarettes versus cigarettes. What are the researchers measuring? So what are they measuring in this experiment? Okay, they're planning to monitor how many cigarettes they smoke per day. All right, state the hypothesis that local researchers are testing. Remember that this should be an if-then statement. So I'm going to write, if smokers switch to e-cigarettes, then they will smoke more cigarettes per day. All right, so make sure that your hypothesis ends in a period. It is a statement. It's your educated guess. All right, number 5, identify the independent variable in this experiment. Remember, this is something that you are changing or manipulating. And I'll give you a hint. If you set your hypothesis up correctly, that if-then statement should have both your independent and your dependent variable. So your hypothesis will actually be if IV, then DV. So reading my hypothesis, I wrote if smokers switch to e-cigarettes, and my IV, my independent variable, should be somewhere in that if statement. So my independent variable, what's being changed here, is actually e-cigarettes. So my independent variable is going to be e-cigarettes. That's what I'm changing, because half of my smokers are going to smoke e-cigarettes and half are going to smoke regular. All right, so let's do the same thing. My dependent variable is what I'm measuring. And if I did this correctly, it should be in my then statement. Okay, so then they will smoke more cigarettes per day. Right, so I phrased this a little bit differently, but the dependent variable is going to be the number of cigarettes smoked. So number of cigarettes smoked. Because that's what we're measuring. We're going to count the number of cigarettes that were smoked, and that is our dependent variable. All right, and finally, number 7, why did the experiment include 5,000 smokers who were not using the e-cigarette? So these 5,000 smokers were using regular cigarettes. Why is that important? Why do we have to have that group? Well, I'll remind you that the name of that group that's just smoking regular cigarettes is called the control group. And why is this important? Well, we have to have a baseline of data. To compare our experimental results to. So we have to have a group of regular smokers and their data to be able to compare the e-cigarette users to the regular cigarette users. We have to be able to compare that experimental data to our control data to prove a relationship between the independent and dependent variable. All right. So as always, if you have any questions about this lesson, please write down your questions. You can either type them as a comment on this video or you can send me an email. But as always, I keep saying as always, you've done this twice now. Go ahead and click on the exit ticket and make sure that you answer that exit ticket before coming to class tomorrow. So same deal, this lesson and this exit ticket will be due tomorrow morning, Tuesday at 8:30 a.m. All right, I'm signing off, but let me know if you have any questions and I hope you all have a wonderful day.